Okay, we're continuing on with lesson 25, and we're up to looking at problem where we're given sine theta is equal to a particular value such as 2 over 3. And we want to find the other 5 trigonometric values for that, or functions. First thing you want to do is set up a triangle. It tells you that it's in quadrant 2. So you have to look at this in terms of the ratio that sine has, which is opposite over hypotenuse. So we want to draw our triangle in quadrant 2. We always start at the origin, work out. And then since opposite, we always look at the opposite of angle theta, the side opposite that, which is 2. And then 3, of course, is the hypotenuse. Opposite of our right angle, which the line, the vertical line, is always perpendicular to the x-axis. All right, so one thing we have to do here is to go ahead and find our third side. So let's take a look at how we're going to do that. All right, so here we have here's our coordinate plane, and here's our triangle. 2 is opposite, 3 is the hypotenuse. Here's our angle theta. So we're trying to find side x. All right, so this will be, if we're using the Pythagorean theorem, c squared equals to a squared plus b squared. You always want to start with the hypotenuse, c, which would be which one of the 3 terms here? 3, right. The hypotenuse. So that'd be 3 squared. And then you could use either 2 or x. That really doesn't matter which one goes first. So we'll put 2 squared plus x squared. So 3 squared, that's 9. And then 2 squared, that's 4 plus x squared. So we solve for x, so we have to apply minus 4. And we get x squared equals to 5. So now what are we going to do to solve for x? Harley? We've applied squared. 3 squared is 9, right? 2 squared is 4. We applied minus 4 to both sides, got 5. But now we have to isolate. We have to do one more step. Apply a square root. Apply the square root. But you always have to remember what? Outside of the radical sign. Plus or minus, right. Well, how do we know which one it is? Is it x equals to a plus square root 5? Or is it x equals to a minus square root 5? Which one could it be? Well, let's look at, we're in the second quadrant, right? What value is x in the second quadrant? It's negative, right? So we're going to use a negative square root 5. Okay? So that's why it's important that you draw your right triangle first, because usually people tend to get how to do these trigonometric values, functions, but what they mess up on, if they're going to mess up on any place, is the signs. So you have to make sure you get the signs right. So here we have sine theta, cosine theta, tangent, and we'll do those first. Okay, we said earlier that sine theta, we were given that sine theta is 2 over 3 in quadrant 2. All right, and we had to find the other trig functions. All right, well, we already know sine is 2 over 3. Okay, now cosine, that's what ratio is cosine in terms of opposite, adjacent, hypotenuse? Travis? Well, sine is, we said that sine was opposite over hypotenuse, right? Think of it in terms of this way. So, remember this? So, ka, toa. Sine is opposite over hypotenuse, so cosine would be what? Adjacent over hypotenuse, right. So this would be, adjacent would be a negative square root 5 over what? What would the hypotenuse? 3, right. And then tangent, what would that be, Sydney? For a ratio. Okay, well, yeah, well, actually, tangent is going to be sine over cosine. I think what you're thinking of is cotangent. But tangent is opposite over adjacent, right? So what's our opposite side? 2, right. Over adjacent, which would be adjacent. It's adjacent to our angle. So that would be negative square root 5, right. Which we have to rationalize, right, the denominator. So we have to apply what? We have to multiply that by. Well, yeah, we could just put square root 5, right? Square root 5 over square root 5. So that would make it negative 2 square root 5 over the square root of 25, right, which would be 5. All right? Questions with that? All right, now, what's the reciprocal identity for sine? Dylan? Well, there's secant, cosecant, and cotangent. Cosecant, good. So that'd be cosecant theta, right? So basically it's 3 over 2, right, the reciprocal to sine. And so Travis, what would be the reciprocal identity for cosine? Right, and that would be what if cos. Okay, but what's the reciprocal identity? If cosecant's reciprocal for sine, secant, right? Good. And so that would be a negative 3 over the square root of 5, but we have to rationalize that, like you said. And so that'd be square root of 5 over the square root of 5. And so we're going to get negative 3 square root 5 over the square root of 25, right, which comes out to be just 5. All right, questions with that? All right, and then what's the reciprocal identity for tangent? Harley? Cotangent, right. Okay, and so for this, see, since we had to rationalize it, it's easier if you go back to the original ratio and then just flip that or apply the reciprocal to that. So that's a lot easier than having to apply the reciprocal to this and then having to rationalize the denominator and then simplifying it. So what would the reciprocal for identity be for cotangent? since tangent is originally started off as 2 over negative square root 5, it's easier if you just apply the reciprocal to this value here. So what would be the reciprocal of that?
Negative square root 5 over 2.
Good. That's right. Negative square root 5 over 2. And there we have our 6 trigonometric functions. Okay? Questions with that? All right. Okay. Let's see what we have for the next problem. Okay, here we want to find sine theta and tangent theta. So we don't need to find all 6 here. We just need to find sine theta and tangent theta, given cosine is a negative square root 3 over 4, and sine is less than 0. All right? So, since cosine is negative, now think of cosine as negative like x. Cosine is synonymous with x, right? So cosine is negative. So what 2 quadrants are x or cosine negative? Dylan? If we look at the coordinate plane, right? Here's x, here's y. We have, okay, so from here we have quadrant 1, 2, 3, and 4. So what quadrants is cosine, same as x, negative? Two and 3. Good. So we've got quadrants 2 and 3 for cosine is negative. And here we have sine is also negative. Or sine is less than 0, so sine is negative. So where would, now sine is synonymous with what? X or y? Y, right? So where is, if y is negative, then sine is also negative. So what quadrant would that be? Well, here's y, right? Here's y. What values are these? Positive or negative? Going up y. 1, 2, 3. Dylan, Harley, or rather, what values are y going? Positive. So therefore, these would have to be what values? Positive or negative? Negative, right. So if y is negative, sine is also negative. And 3, and what else? 4, good. Well, we want the intersection of the 2. So since cosine is negative in 1, 2, and 3, and sine is negative in 3 and 4, so what quadrant are we operating out of?
3.
Quadrant 3, right. Because that's where both sine and cosine are negative. So we're operating out of quadrant 3. And since we have tangent, right, 4 over 3, we have to look at the ratio of tangent theta is opposite over adjacent. All right? So this is what we've got so far. We've got our coordinate plane. We're in operating on a quadrant 3. Here's theta. We're given tangent theta is equal to a negative square root 3 over 4. And we also know that sine theta is less than 0. So the only purpose that this sine theta is less than 0 gives us is to help us determine what quadrant we're operating out of. Since this is tangent is opposite over adjacent, the negative square root 3, that's our side opposite of theta. 4, that's adjacent to angle theta. Now, how do we know where the negative went for square root 3 or 4? So actually this is not a negative. That's just this is not tangent. This is cosine. There we go. That's better. And we want to find sine theta and tangent theta. Okay, so actually this is need to fix this. Since cosine is adjacent over hypotenuse, then this would be negative square root 3. 4 is the hypotenuse. So we have to find y. So how do we find that? Well, what did we do in the last? Well, we probably didn't. Yeah, we did. What did we do in the last problem to find the third side? Here's x. Travis?
A squared plus b squared.
Right. We used. Do you know what that's called?
No.
It's called the Pythagorean theorem. Okay. Okay. So that's called the Pythagorean theorem. So that's what we have to do here. C squared equals to a squared plus b squared. Okay? So go ahead and find that third side. Okay, So you should have gotten plus or minus a square root of 7. So which one is it? Positive or negative? Sydney?
Negative.
Good. It's negative because we're in quadrant 3 and y is negative in quadrant 3. So that'd be negative square root 7. All right, questions with that? All right, so now we're ready to go ahead and come up with our ratio. We're just trying to get, we're just trying to get sine theta and tangent theta. All right, so knowing our SOHCAHTOA memory device, TOA, come up with the other values for sine and tangent. All right, go ahead and do that. Okay, sine is opposite over hypotenuse, so what values would you put there? Travis? Right, negative square root 7 over 4. And how about tangent?
Negative square root 7 over negative square root 3.
Right. Negative square root 7 over negative square root 3, but we know that negative divided by negative, what happens there? Yeah, they cancel, they become positive, right? And can we leave it that way? Okay, what else do we need to do?
Top and bottom square root of 3.
Right, multiply square root of 3 over square root of 3. We're going to rationalize the denominator. And what do we get here for the numerator?
Square root of 10 over 3.
Well, careful now because we're multiplying.
Oh, so square root of 21 over 3.
Right, square root of 21 over the square root of 9, which becomes 3. Okay? Questions with that? All right, good. Now see, this is what I was telling you about earlier, where you got to watch it with tangent, because here you had negative over negative, you get a positive. So if you're ever given a tangent and it's positive, when you put it in the triangle, you may end up having your values being both negative. So you have to look at what quadrant you're in. You have to watch it with the tangent. Okay? Questions with that? All right. And here we're given cosecant theta is a negative 3. And cosine is greater than 0. Find the other trigonometric functions. Okay, so we'll rewrite this. We're given cosecant theta is a negative 3 and cosine theta is greater than 0. Okay, find the other, and I'm just going to abbreviate trig functions. Okay, now here you have to look at, first of all, cosecant negative 3. When you see like an integer like this, it helps to put it over 1. Okay. Now another thing is we want to identify the reciprocal. identity. Okay, which would be what? So let's look at it this way. Here's sine, cosine, tangent, tangent, theta. And then we also have cosecant, secant, and cotangent. And we already know cosecant, right? We know that's a -3. So to find where our values are on our triangle, it helps to go ahead and find what the reciprocal is, which would be sine, right? So if cosecant is -3/1, then sine would have to be what? Now, Harley?
-1/3.
Good. -1/3. And since we know our SOHCAHTOA, right? Okay. This sine we know is what ratio? What over what? Opposite, hypotenuse, adjacent.
Opposite over hypotenuse.
Right, good. Opposite over hypotenuse. Okay, so if cosecant is negative, so is sine, right? So we're looking at sine being negative, which puts that in what two quadrants? Dylan?
3, 2,
3 and, remember now sine is like,
3, 4.
yeah, sine's like y, right? So that would be 3 and 4. And cosine is positive. So if cosine is positive, cosine is like x, right? So that would put us in which one, 3 or 4? 4, right. Okay, so we have opposite is a -1, hypotenuse is 3. So we have to find what x is. And how do we do that? Right, the Pythagorean theorem. Good. So this would be, what would come first for our c squared equals to a squared plus b squared? Sydney?
3 squared.
Good. 3 squared equals to,
X squared.
okay, x squared plus
-1
-1 parentheses squared. All right, good. So that would be 9, right? Equals to x squared plus 1. And so we subtract 1 from both sides and we get 8. So we apply the square root, right? And so is that going to be, so that simplifies, that would be like 4 times 2, right? So that's like the square root of 4 times the square root of 2. So what are we going to get as a simplified form for that side? Now, Dylan?
Plus minus
Okay, plus or minus
2,
2, square root
2.
2, right, 2 square root 2. Good. So is it going to be positive or negative? Well, here's x, right? Positive, good. So this is going to be 2 square root 2 here. Okay. So from there, come up with the rest of the trigonometric values. Okay, we should have gotten cosine is adjacent over hypotenuse, right? So that would make it 2 square root 2 over 3. So for secant, we have to rationalize that. So that becomes 3 goes in the numerator, 2 square root 2 is in the denominator. But we have to rationalize that, so we got to multiply that by what? We got to get rid of that radical, right? So what do we have to multiply that by, Travis? Right, square root 2 over square root of 2. So we get 3 square root 2 over, this would be like the square root of 4, right, which is 2, which becomes 3 square root 2 over 4. Okay? Questions with that? All right, tangent is opposite over adjacent. So that's going to be a negative 1 over 2 square root 2. But we have to rationalize that. So we got to multiply square root of 2 over square root of 2. And we get negative square root of 2 over 2 times the square root of 4, right, which is 2. So that becomes 4. Square root of 2 over 4. Okay? So this is 2 square root of 4. So that becomes 2 times 2. And so that becomes 4. All right? And then the last one, we just take that beginning part and just apply the reciprocal to that. So that becomes what? Sydney?
4 square root of 2 over 2.
Well, we just got to take this before you simplify it, before you had to rationalize it.
2 square root of 2 over negative 1.
Right. Oh, yeah. And so that would just be a negative 2 square root 2. Okay? Because if you had it over 1, right, over negative 1, that's positive over negative, so that just becomes negative 2 square root 2. Okay? Okay, questions with that? All right. That is the rest of lesson 25.